Electricity is a powerful force that can be dangerous if not handled properly. One of the most important safety measures in any electrical system is grounding. In simple terms, grounding means connecting electrical equipment to the earth. This connection provides a path for electrical current to follow in the event of a fault or short circuit. Without proper grounding, that electrical current could flow through unintended paths, like a person's body, leading to a potentially fatal electric shock. By providing this direct path to the earth, grounding helps to minimize the risk of electrical shock and protects both people and property. Whether in a home or a large commercial building, grounding is a fundamental aspect of electrical safety. In a residential setting, grounding is crucial for keeping families safe from electrical hazards. The grounding system in your home starts at the service panel, where the main electrical supply enters. From there, a grounding conductor, usually a bare copper wire, connects the panel to a grounding electrode. This electrode is typically a metal rod driven into the ground outside your house. All outlets and appliances in your home are then connected to this grounding system through a third wire in the electrical cable, the ground wire. This ensures that if a fault occurs, the electrical current has a safe path to the ground, preventing dangerous voltage from reaching you or your family. Commercial buildings have more complex electrical systems than homes, and their grounding requirements reflect this. The higher voltages and greater electrical loads in commercial settings demand a more robust grounding system to handle potential faults effectively. Commercial grounding systems often involve multiple grounding electrodes, larger gauge grounding conductors, and more stringent bonding requirements. For example, metal water pipes, structural steel, and even the building's foundation may be incorporated into the grounding system to provide a low-resistance path to the earth. This comprehensive approach ensures the safety of employees and equipment, minimizes the risk of electrical fires, and helps to prevent damage to sensitive electronic equipment. Section 4. Residential versus commercial. Spotting the differences. While the basic principles of grounding are the same for residential and commercial buildings, there are some key differences. First, scale and complexity. Commercial grounding systems are more extensive and complex than residential ones, due to the higher electrical loads and the presence of specialized equipment. Next, grounding electrodes. Commercial buildings often use multiple grounding electrodes, such as ground rods, ground plates, or a combination of both, to achieve a lower resistance to the earth. Lastly, bonding requirements. Commercial codes have stricter bonding requirements, connecting more metallic components to the grounding system to create a safe environment. These differences reflect the increased safety risks associated with higher voltage and more complex electrical systems in commercial settings. Section 5. Why grounding matters, safety first. Proper grounding is not just a matter of code compliance, it's about protecting lives and property. A well-grounded electrical system provides a safe path for fault currents to flow, minimizing the risk of electrical shock, fires, and equipment damage. By understanding the basics of grounding and the differences between residential and commercial requirements, you can help ensure that your electrical systems are safe and up to code. Remember, when it comes to electricity, safety should always be the top priority. And if you need help, call or text 844-411-0240, and someone from Positive Electricians will be happy to help you with your grounding problems.